to FOIL those out, and I get 15x cubed plus 12x squared minus 10x minus 8. And so the derivative of that would be just a quick reminder, in case you forgot gravity of what just happened, to do the actual definition of derivative, the derivative from where it comes from, without a shortcut rule, we would have had to do 15 times x plus h cubed plus 12 times x plus h squared minus 10 times x plus h minus 8, and then minus the function. Multiply all of that out. We would be here a while. It would be nasty. That took us a couple seconds. Create a function that you could not apply the power rules upon a derivative. And there could be a lot of answers to this. Did anyone come up with anything? There's a lot of functions we haven't touched yet, right? Like? Okay, multiplication and division. Now, the ones that were on last night's homework, we could multiply out. Let's do maybe that, though. Could I divide that out like I did on the homework last night? So I'm stuck on that one because that denominator is more than one term. That's where I'm going to need another rule. Wow. In any trig function or anything like that, I need more rules. So we know that the power rule was amazing, but it's not an end-all. We have more work to do, more things to figure out, how to find derivatives of, hopefully not the long way. Right? So we would like to explore more rules, more shortcuts. And the first one that we're going to look at is the product rule. You do not have to write this down. It's in your textbook. This is a proof. Every time I teach you a new theorem, I'm going to try to show you the proof of it, unless it's something that I know is way above our heads. And the reason I'm going to do that is you get exposed to the why and how, and those of you going on in math in college will be exposed to proof a little bit, because you will, those of you who go way on in math will need that exposure to proof. Anyway, we know that the derivative is the limit as h approaches 0 of f of x plus h minus f of x all of h. To finish what I was saying, you don't actually have to know the proof of the product rule. Not in Cal 1 or anything like that. Okay, the next one is the derivative of a product of two functions. Right, that would be the, would you agree that would be the derivative of this thing? F of x plus h times g of x plus h minus f of x times g of x all over h. The hard thing is doing that, right? That looks pretty nasty. With some very, very creative algebra, would you think to do this? No, not at all. They added and subtracted f of x times g of x plus h for whatever crazy reason they could do that. And they could have also done it g of x times f of x plus h, which would have eventually gotten to the same place. With some rearranging and factoring out a g of x plus h in the first one and an f of x in the second one, this can now be written as two separate derivatives. The derivative of f of x times g of x plus the derivative of g of x times f of x, which leads us to what is known as the product rule. The derivative of two functions multiplied together is the left function times the derivative of the right plus the right function times the derivative of the left. In short, left be right plus right be left. So, if we want to do the derivative of a product, we do the derivative of the left times the right, the derivative of the right times the original left. Don't write all of that down, but part in the yellow so you really need to know. Part or in the yellow is what you need to know. The derivative of two functions multiplied together is left times the derivative of the right plus right times the derivative of the left. Or again, in short, lefty right plus righty left. We've got to learn some more derivative rules, so not yet, but it will be in the first 9 weeks. Probably about a week out. You'll probably get the first copy of it this week sometime. We still have chain rule, which is kind of big. That takes a couple days. This very rarely comes up, but just if it ever does, I want you to know how to deal with it. Again, it's very rare. But the product rule can be extended to more than 2 things multiplied together. If that happens, you take the derivative of one piece, leave the other 2 alone. Then the derivative of the next piece, leave the other 2 alone, and the derivative of the third piece, and leave the other 2. So that's how you would extend it out if you were to ever have to. I have never seen it show up on the AP exam where you couldn't FOIL out 2 pieces first and then work it that way, but just mental note if you've ever used it. The next thing we're going to learn is the quotient rule, and I am not going to show you the proof of the quotient rule. It is in your textbook. It's actually almost identical to the proof of the product rule. It does that same addition. This one's called the quotient. This piece right here. The quotient rule is how you take a derivative of 2 things that are divided. And I have a shortcut to remember it too. Shortcut. Helpful. To do that derivative, you do the bottom function times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. Or low be high minus high be low, or low squared. Low be high minus high be low, low squared. It's silly, but it's helpful in remembering which one goes first. It does matter which one you put first because it's subtraction on the top. Product rule you can mess up because it's addition. It really doesn't matter if you do left or right first. But quotient rule, it does matter. It's the bottom times the derivative of the top minus the top times the derivative of the bottom. You will memorize those quickly. Okay. Let's look at this first problem. We now have 2 rules we can use. I want to show you 2 ways to work this problem. The best way to work this problem is how you did it yesterday. Someone tell me why.
Can you put both pieces on the top?
Right. Since the 3x is a single term on the bottom, I can just divide. And I want to show you this because the quotient rule is more complicated than the power rule. So there are 2 ways to work this. I hope you always work this problem like you did yesterday, which is rewriting it as 2/3 plus 5/3 x to the negative 1. See how I got that? And then therefore the derivative would be
So whatever x down to
2x divided by 3x. And then 5 divided by 3x gives you 5x. Why am I telling you this? In 2 weeks from now, I will have the hardest time in the world getting you to do this that way. You will try to do the quotient rule, which works. But I'm going to show you why, if you can avoid it, you'd rather not do the quotient rule. Not that it's that terrible, but that was really easy, wasn't it? I don't think we can beat that. Yeah, question.
I don't know, like, did you add first, did you move the negative 1 over first?
From here to here.
Yeah, like when you got negative 5/3.
So I move the negative 1 in front and reduce the power by 1. So that it's half.
Oh, so the 2 just went away. Okay.
Yeah.
I was trying to get the first 2 clear.
You can't since the 2/3 doesn't have x. So they're not like terms. Good question. So now I'm going to do the quotient rule, and sometimes we will have to. You'll see on the next slide problems that we have no choice but to do the quotient rule. And it's not terrible. I'm going to do the bottom low, just the bottom by itself, times the derivative of the top. What is the derivative of the top? And everyone see where she got that too. Bottom times the derivative of the top minus the top times the derivative of the bottom. What is the derivative of the bottom? All over the bottom squared. Do a little simplification. Minus 6x minus 15 top became that. The 6x's cancel. Negative 15 over 9x squared does reduce to negative 5 over 3. X squared over 5. Did I get the same answer both ways? Which one was more efficient? Moral of the story. If you can simplify and do a power rule, always, forever and always do that, if you can. Again, I'm about to show you some places that you can't. But if you can, simplify. Because that's always going to be the fastest route. Here. So I'm going to divide 2x by 3x. And then I'm going to divide 5 by 3x. So I have 2x over 3x plus 5 over 3x. These just cancel and give me 2/3. This one, remember, I've got to have the x as a power to be able to use the power rule. And then x on the bottom is the same as a negative 1 exponent. I'm going to do the exact same thing with this problem with product rule. Is this the same one from the bell ringer? No? I'm going to work this 2 ways. I'm going to work this using the product rule, and I'm going to work it using the power rule. We need to learn the product rule for when we have to use it. And I'm going to show you that you do get the same thing. So using the power rule, what do I have to do before I can work this problem using the power rule? be probably always the best way to work that problem. There was nothing difficult about that, right? Okay, let's look at the next way to do it. That's the product rule. Using the product rule, what will I do? Left. So I just leave the left-hand side alone. Which part's the left? So this piece is the left, right? So I'm just going to leave it alone. Right, so there's this one.
Does it matter if product?
It doesn't. Product rule, lefty right, righty left, or righty left plus lefty right. It really doesn't matter. Fellowship rule matters because it is a structure. Product rule. In fact, you'll see me work it both ways on this. You have to have something to memorize. So, derivative of the right is 2. Does everyone agree? Plus right times the derivative of the left.
Yes.
Just for fun, let's see if those are the same thing. Are they the same thing? 16x squared plus 8x squared is 24x squared. So it seems like our product rule is working. Now you're probably thinking, but Miss King, you haven't shown me why I need it yet, right? The next thing is why I need it, right? X to the 4 times sine of x. For a few moments, I will get to where you know why they are what they are. But for a few minutes, I want you to write down this table. For your homework tonight, you will need this table. It's some derivatives that you just need to know for tonight. Of course, the first one's the power rule. I hope you know that already. The derivative of sine of x is cosine of x. You don't know why yet, but it is. The derivative of cosine of x is negative sine of x. The derivative of e to the x is e to the x. The derivative of natural log of x is 1 over x. And the derivative of sine inverse of x is 1 over 1 minus x squared. If you were to forget any of these, you see this page on your calculus helper? It says basic differentiation rules. I just listed a few of those on here. These have an extra U thing that you don't quite know what means yet, but they are on that sheet. They're quite important. You can if you want to. Those are your homeworks that are coming up. I'll pull it back up in a minute if you. Those same rules that I just gave you are what you will need to know for your homework. Don't worry, I will show you where they come from. So let's look at this one right here. X to the 4th times sine of x. Is that a product? And make sure you figure that out before you start. definitely multiply by sine of x. I can take each of those derivatives individually, but that's not how you do a derivative of a product. At the beginning, that'll be an early mistake. Y'all make it very careful. Don't just take the derivative of each piece. The only time you can do that is with pluses and minuses in between. With multiplication, we have to do a product.
With the quotient form, if it has just one thing on the bottom and it doesn't have an x, is the quotient form the only one you can use, or can you still use the power one?
You can still use the power rule. In fact, if there's anything on the bottom that doesn't have a plus or minus in between, you can use the power rule. You can divide everything by that.
You can just use the quotient if it's too big to fit.
Like x plus 3, or something like that. If the denominator is bigger than just one term.
But then how does that fit into the equation? Like, it's only g of x squared.
The g of x is a function. So it could be x plus 1.
Okay.
So you do x plus 1, parentheses 3.
Okay.
I'll show you. Okay, x to the 4th times sine of x. So how would I take that derivative? Left. So I leave the left alone. D right. I don't know what the derivative of sine is, but I just told you, didn't I? And what is the derivative of sine? Plus right, which is sine of x, times d left. What's the derivative of the left? Why did I put that in parentheses? It might look like it's all inside that sine function. You could rearrange it, but that's it. Right, that is the derivative of that function. You're right. Right. Let's look at this one. That's the final line. No, I'm not saying it couldn't be simplified. We could factor. It's just a kind of derivative. If it tells me to do more, cross that bridge when I get there. For now, it's just fine. If there is obvious simplification to do, do it. But you don't have to do simplification here. Like on that first one, we had 6x minus 6x. Up there. Can I use a power rule on this problem? Why not? There's addition on the bottom. Do I still need to do a little bit of a rewrite before I start the problem? Because I don't know how to find square root of x's derivative, right? What should I rewrite that top to be before I start this problem? What's the function? Make sure that you don't get the function rewrite and the derivative confused. I haven't actually taken any derivatives yet. I just was doing some simplification before I started, so I could see how to do it. Okay? And then how do you do the derivative of a quotient? Low, which is x cubed plus 1. D high, derivative of the top. What is the derivative of x to the 1 half? Minus top times the derivative of the bottom. What is the derivative of the bottom?
It should be 1 half.
Three x. Any questions so far? Top times the derivative of the bottom. All divided by the bottom. I am going to do some simplification on the top since I have power functions multiply together, and I think this one's a really good one for you to see because we always can use practice on our properties of exponents. So it's been a little while since you were a Greek cal this summer. Always tilts us a little. So how do you multiply 1 half x to the negative 1 half times x cubed? How do you do that? together with the same base. Add the exponents. So I'm going to do the 3 plus negative 1/2, which is 2 1/2 or 5 over 2. Two plus 1/2 is also 2 1/2 or 5. And then I can combine the two things that have the 5/2 exponent. 5/2 x to the 5/2. Now, we could simplify this all day long. To give you a little bit of insight on that, we could stop here, and I want you to know that before I keep working because I'm just going to do a little algebra review for you. I could stop here. Everyone agree? This is the derivative. I was actually done with the derivative in the first, with the red and blue part. So I'm just showing you some simplification stuff. On your homework, if it's not multiple choice and I just say find the derivative and you stop there while I give it to you. Yes. So anything from here on out is just equivalence. Now you might be asking, why would I ever need to know how to do that? You know on the AP exam, there are multiple choice questions. So from here on out would only be to match a multiple choice answer. So on your homework, you don't have to do the rest of this part. But I do want to show you a couple of things with simplification that we could do. Anything that you can easily see that we could do to simplify this? What makes it look nasty? The fractions in the top. One quick way I could simplify this, you would agree I could multiply the top and bottom by anything I want? Fractions, as long as I do the same thing on top and bottom. I would pick 2. Why would I multiply the top and bottom by 2? Okay, the 1/2. So this would be x to the negative 1/2 minus 5x to the 5/2 over 2 times x cubed plus 1. Already looks a little better, doesn't it? Isn't it still the 1 over the square root of x? 1 over the square root of x on the top. You probably don't really like that negative exponent at the top. I could play the exact same trick by multiplying the top and bottom by x to the 1/2 power. If you wanted to. Again, this is all just if you wanted to simplify. But, so I multiplied by 2 on top and bottom there. Couldn't I multiply by x to the 1/2 on top and bottom? Which you actually could have done that all at once, yeah. What do I get if I multiply x to the negative 1/2 times x to the positive 1/2?
Because they add together.
1, right? Negative 1/2 plus 1 is 0. X to the 0 power is 1. Think about that one, what we just did. Isn't this 1 over x squared? Or 1 over the square root of x times the square root of x? 1 over the square root of x times the square root of x. It's just of each other. So the 6/2. Everyone agree that'd be 6/2? 3. That would look much nicer.
Can't we just leave it almost?
Yes. I said that. Now, why would you do this part? Only the match multiple choice. From the black part at the top on, you would never do that on an open response. On your homework, you wouldn't do that. to match multiple choice. You know what I mean by that. I wouldn't. I didn't particularly like doing it here. I figured we could use some practice properties I just wanted to do. It's been a while. Let's actually apply some. Okay, let's look at the next one. Can you use a power rule? What rule do we need? Quotient rule. If you're really creative, you can turn it into a product rule if you wish. If you really like product rules better, you could call it x to the negative 2 times cosine of x. Is that okay? Yeah. I'm just going to work it as a quotient rule because that's probably what we would do. And how do you do that? Low, D high.
Wait, why is that? Like, why is that?
Low, D high, and what is D high? Negative. And again, you don't know why yet, it just, because I told you so. Minus high, D low. All over low. The only simplification I would do is just a little bit of rewriting. But again, I want to talk to you about what a multiple choice answer might look like. That's all I would do. And the reason I would do that is so you don't lose the negatives in the 2x. I would put the coefficients in front and rewrite the negatives.
So is that x to the power 4 because you added those two, or because you timed those?
Multiply. X squared, power raised to a power you multiply. Do I have those properties on here? Yeah. So if you want to, they're probably on your note card. I will tell you that the multiple choice answer to this would look like this. Why? Okay, they factored an x out. Do you have to do that? Do you have to do this last step on your homework? No. Do you have to be able to pick it out on multiple choice? Yes. Mental note. I'm going to try to show you this overly simplified multiplication again. Okay. How many times would you have to use the quotient rule? And I actually think I might be answering a problem on your homework. Okay. How many times would you have to use the quotient rule on this problem? It doesn't actually say to do it. It just says how many times would you have to? I want you to look at it and think about it for a second. How many times would you have to do
He wants us to look at it actually trying to do it.
I just want to know how many times. I don't want you to actually do it. I want you to answer the question. How many times would you have to use the quotient? So what do you think? How many times would you have to use the quotient? 1/3 x plus 4/5 plus 1 plus x to the -1. Finding both of those pieces. So the only place that actually needs a quotient rule is that last piece. That's a very important skill. Because how long would this problem take you if you did 5 quotient rules on it? Really long time. How long will this problem take you if you only did that 1 quotient rule and the rest powerfuls? Not very long at all. So I just wanted to point that out. Watch for that. Okay, let's look at example number 5. This is one of AP's favorite types of questions. So you can imagine it's going to be on your test. One of AP's favorite types of questions. They like to know if you can apply the rules without functions. So, it says use the chart below to find a prime of 4. If a of x is L of x times W of x. Well, what would a derivative look like? What would be the derivative of a of x? With symbolic figures. How would you do that derivative? Left, d right, correct? Plus right, d left. And then how would you find a prime of 4? Would you just put a 4 where all the x's are? L of 4 times W prime of 4 plus W of 4 times L prime of 4. And AP is going to give you a way to find those values. So do I know L of 4? You do. Do I know W prime of 4? Do I know W of 4? Do I know L prime of 4? Did they throw in a lot of distractors? Yeah, but so the answer is -14. So that's a real AP style question. It comes up a lot. Any questions?
Alright, I do that had like the same thing.
Okay.
Kind of. There's a chart and then it's asked which of the ones must be true. It's like f prime of 1 is less than 0, f prime of 1 equals 3, and f of 1 equals 3.
Well, you know that's prime. We have continuous differential function. Check on which of the following statements is true. I don't really know anything about f prime, do I? At all? So all I know is that f is true.
So that's what we have.
I don't know what I know from the about the derivative is very okay, this is your homework. Tomorrow we're going to learn why the truth functions work like they work. So all we're going to pick up tomorrow is trig functions. These are both due Wednesday. Both of these assignments are due Wednesday, so all of it. Yeah, tonight's homework, that bookwork, and then tutors and even are all due Wednesday. Tonight's homework and this bookwork is big. Tomorrow I'm only adding 5 problems. See that? So spread the wealth, I guess. Do as much as you can tonight. If you happen to finish all of this tonight, then all you'll have tomorrow is 5 problems. If not, though, I understand because this is a big assignment. So do some tonight, but don't save it all for Tuesday night. That would be a lot of homework all in one night. Go ahead and do at least the worksheet or something, but then go do a few more. This is let's see. 7 problems here, 5 problems here, so there's 12 total on the market line. And if that works, then it's right back. And the only ones you can't do together is superset. Yes. And those are trait functions. The trait functions that are on tonight somewhere, they're on that chart. And I gave you this. So this table has some more trait functions you can imagine.